Yeah. Good evening, children. Welcome to Akshar IIT Foundation. This is Srinivas from Maths faculty. Let us go to the today's class. We have discussed up to 16 problems in our previous classes. Let us see the 17th one. Then we need to discuss one more time about the congruence rule and all, because we need to find out the reminders. Reminders when we divided with very large numbers like 4000 power 2222, like that. Very large exponential form is given. How to find it we need to learn. Okay. So let us see this. Sum of the cubes of divisors of 12. We are not asking about sum of divisors. It is sum of the cubes of the divisors. That means we need to find each and every divisor. We should know every divisor here. So every divisor means, in the sense, we need to check each and every table, like 1 onwards. Yeah, 1 12s are 12 factors. All factors we should write. 2 table 6 times. 3 table in 12 4 times. Again 4 table 3 times. 3 4s, 4 3s, both are same. So it is pattern is repeating. So therefore the factors are 1, 2, 3, 4, 6, 12. Now sum of the cubes, we should take cubes of these factors. So 1 cube plus 2 cube plus 3 cube, 4 cube, 6 cube and 12 cube. Add all of them. 1 cube value is 1, 2 cube value 8, 2 into 2 into 2, 2 2's 4, 4 2's 8. So 3 cube value is 27, 4 cube 64, 6 cube 216 and 12 cube 1728. Add all of them, you will get the answer 2044. Okay, na? So first of all we need to find out the factors of 12, then cubing them, find the answer when you add it. Let us go to the next one. So remainder, we need to find the remainder when 24 power 1947 is divisible by 17 table. For example, 24 cube, 24 into 24 into 24, 3 times. But 24 power 1947, that means we need to multiply this number 1947 times. See how much huge number will come. If you divide that entire number with 17, there is a remainder, it seems. We need to identify them. For this very huge problems, we should use the congruence rules. What is the congruent rule actually? A is congruent to B modulus n, B mod n. That means A minus B is divided by n. A minus B is divided by n. That in the sense, here B is the remainder. Here B is the remainder. Let us see one example. 15 is congruent to 3 modulus of 4, 3 mod 4. According to this condition, 15 minus 3. 15 minus 3 how much? 12. That means if you directly divide 15 with 4, 4 3 is 12, and what is the remainder here? 3. Right? Okay. For example now, if 18 is divided by 17, what is the remainder? 1. Very good. If 16 is divided by 17, 16 only remainder itself, right? Because 16 is smaller than 17. In these situations, what is the difference between these two, 16 and 17? 1. So we have to consider minus 1. If you take it as a negative reminders, the negative remainder will be minus 1, because 16 is less than 17. Am I right? So this will be useful for some other times. That's why I am telling you like that. But actual remainder to find, this this divisor minus this remainder. That means 17 minus 1, 16. Okay, na? In a positive way, plus 16. In negative way, it is minus 1. When 16 is divided by 17. Clear until then? Okay. Now let us see this. The remainder when 24 power 1924 is divisible by 17 or not. Before that, let us leave it for some time. The exponential form 1947. Without that, what is the number here? 24. So how can you write 24? 24 is congruent to 7 mod 17. 24 minus 7, 17. 17 is divided by 17 only, no? So we can express 24 is congruent to 7 mod 17. Okay. Here you need to remember Fermat's theorem also. Clear until then? Right. But I want 24 power 1947. According to the congruence rule, if A is congruent to B mod n, A power m is congruent to B power m mod n. That means we can extend that exponential form both sides equally up to m, A power m, B power m. But here what we want? 24 power 1947. So both sides I am applying the powers 947 is congruent to 7 power 1947 mod 17. Let us consider this equation 1. Okay, children, I am just writing 24 and 17 as 24 is congruent to 7 mod 17, 7 mod 17 because 24 minus 7 is divisible by 17 according to congruence rule. Clear? Okay. But whenever you observe here, the 7 is the remainder here. The 7 must be less than this 17. But here 7 power 1947, it is more than the 17. So let us find out this 17, how many times it will be. Again we need to divide with 17 also. 7 power 1947 with 17. Clear? So according to this, 7 and 17 while you are observing here, Seven and 17, sorry, yeah, 7, 17 are co-primes or not? Co-primes in the sense there is no common factor between them. Like Fermat's theorem, I am writing here, Fermat's theorem, if A comma P are co-primes and P must be a prime number, then we should write A power P minus 1 is congruent to 1 mod P. This is the Fermat theorem, right? Same way, 7, 17, 17 is a prime number and we can write according to the Fermat's theorem 7 power P means what? Prime number. Here prime number is 17. 17 minus 1 is congruent to 1 mod 17. Okay, na? That means 17 minus 1 is in the sense 7 power 16. 17 minus 1 is 16. 1 mod 17. That means if you divide 7 power 16 with 17, we will get the remainder 1. Okay. Now here the trick is the remainder 1 or minus 1 you have to write by adjusting like this. Then only the solvation of problem will be easy for us. That means 7 power 16 is there now. But here what you have to find? 1947. We have only 16. In nearly 16 table 1947 is coming or not? Let us check. That means in that many times we can increase the power. Okay. 16 ones are 16. 3 remainder, 4 down. 2 is 32. 2 remainder, 7. 4s. Okay, sorry. Yeah, ones are 16. Remainder is 11. That means in 16 table, increase up to 121 times. Same how we apply the powers here both sides. Here also apply like this. 1 power 121 mod 17. 1 power 121 how many times? 1 power 121 value is 1 only, because in how many times you multiply 1, the answer is 1 itself. That means 7 power 16 whole to the power of 121. It is in the form of a power m whole power n. What is the a power m whole power n formula? A power m into n. So 16 into 121, how much? 16 into 121 is nothing but 1936, because we got the 11 remainder. You can increase up to here, we will get the remainder 1 modulus of 17. Got it until here? 7 power 1947 is divided by 17. We need to find the remainder. But if we increases up to 1936, we will get the remainder 1. How I have written? According to Fermat's theorem, 7 power 17 minus 1 is congruent to 1 mod 17. That means 7 power 16 value will give the remainder 1. 7 power 16 is divided by 17 means will give the remainder 1. I am just increasing the powers nearer to this value. If it is coming exactly, we will get the remainder 1. But it is not coming. There is a remainder 11. So that means up to 1936. That means if you remove the 11, 1947 minus 11 is 1936. Up to here, you will get the remainder 1. Still, how much we want? 11 we want. That means 7 power 1936 into how many 7s we want? 11 7s. 7 power 11 is congruent to 1 into 7 power 11 modulus of 17. Both sides I am multiplying with the same integer. So it will be 7 power 1947. But here 7 power 11 also very huge number. 7 power 11 also very huge number. Let us check. 7 power 1, 7 square means 49. 49 is divisible by 17 or not? Yes. How many times? 17 threes. 17 threes 51. So we can write this 7 square is congruent to minus 2 modulus of 17. Check here. 7 square is 49. Minus 2 bring this side becomes plus 2. Okay. 49 plus 2 51. 51 is divisible by 17. So 7 square value you can write like this. That means 7 square I can express up to 5 times. Minus 2 power 5. Minus 2 power 5 how much? 32. Minus 32. Mod 17. So this is 7 power 10 value. 7 power 5 whole power, 7 power 2 whole power 5. 7 power 10 value I got minus 32. Okay na? But minus 32 if we write in the form of positive values, 17 1 17, 17 2 is 34. So we can write 2 mod 17. Okay na? Like previously I have discussed the negative integer value forming into positive, we have to subtract from 17, right? Here 17 table you can subtract, right? So 7 power 10 value is 17, but I want 7 power 11 value. That means one more 7 I need. Multiply both sides. So simply 14. 7 power 11 value is 14 mod 17. Remainder is 14. Okay, na? In the place of 7 power 11, we can write 14 mod 17. So equation 1, equation 2. From both of them, we can say that remainder is 14. That means this value only we should write now. Remainder is 14. That means A is congruent to B mod C or B mod N. B is congruent to C mod N. We can say that A is congruent to C mod N. In the same way, we can write like this. Please note it. Same this type of models only I have collected here. You are not there 114. Okay. Right. So the remainder when 3 power 100 is divided by 7. 3 power 100 is divided by 7. What is the remainder? Same process we have to do. Now this is somewhat easy problem. You will understand how to do it clearly. So simply 3 is divided by 7 or not. In 3 tables 7 negative answers will come, right? Because 3 is smaller than 7. 7 zeros, 0, 3 only the remainder. If you go to the negative value, minus 4 will come. Now let us check 3 square value. 3 square value how much? 9. 3 square value is 9. That means we can write 3 square value is, one second. Yeah, this one you can express as 3 square value 9, no? 3 square is congruent to 2 modulus 7. Can we write like this? Because we need to find up to 3 power 100, no? Yeah, 3 square value 9, 9 minus 2, 7, 7 is divided by 7, okay. 3 cube value how much? 3 into 3 into 3, 27. 3 3s 9, 9 3s 27. But 27 will come in 7 table, 7 4s 28 will come. 7 4s 28 28 will come. But 28 in 27, what is the remainder? Positive remainder is 27, negative remainder is minus 1. Negative remainder is minus 1. Now check here. 3 cube value is 27. Minus 1, bring this side plus 1. 27 plus 1, 28. 28 is divisible by 7. So here the small trick is we need to write the remainder as 1 or minus 1. Then we can extend the powers up to unlimited. Because remainder will be same. Whether it can be positive or negative. So I am just checking here. In the 3 powers, 3 cube is nearer to 7. That means when it is divisible by 7, it is nearer somewhat negative remainder minus 1. Now I am expressing, that means I am extending the powers up to 100. 3 table 100 how many times? 33 times. There one remainder. So I am just expanding their powers up to 33. Both sides I am applying the powers up to 33. Modulus of 7. 33 is an odd number, right? 33 is an odd number. So negative becomes negative. 133 times if you multiply, answer is same. Here a power m whole power n, a power m into n. 3 power 99 value we got. If 3 power 99 is divided by 7, we will get the remainder minus 1. Just I have written that 3 and 7 divisibility chances. What are the remainders? When I get 3 cube, I am getting the minus 1 as a remainder. By using the 3 cube, I am extending the powers nearer to 100, nearer to 2000, 5000 also we can expand. Okay, na? So 3 power 99 only is there, but we want one more, because actually we want 3 power 100. So one more 3, then according to the laws of exponent, a power m into a power n is nothing but a power m plus n. Same way, 3 power 99 into 3 power 1, 3 power 99 plus 1, 100 will be. We want 100 only. So both sides I am multiplying with 3. So 3 power 100 equals to minus 1 into 3, minus 3 modulus of 7. But check the options. Options are not given in negative answers, only positives. So what to do? With the divisor, 7 minus 3. The negative one we have to subtract from 7. 7 minus 3 is 4. 4 is the remainder. 3 power 100 is divided by 7. We will get the remainder 4. Like this we have to expand it. Okay, na? Got it, children? So maximum try to get the remainder 1 minus 1. Here I can expand here also 2 power 50. You can both sides here from the 3 square value is 3 square is congruent to 2 mod 7. Here also both sides we can expand up to 100. There already 2 is there, directly expand up to 100 means 50 we need to expand to powers. 2 power 50 again we don't know. 2 power means 2 into 2 into 100 times we have to do. So for us somewhat difficult process for this, but I am checking for 3 cube, we will get minus 1. Right. So let us go to the next problem. Right. So number of positive integers less than or equals to 3600 that are co-primes to 3600 is. So I think in previous class we have discussed about it. Euler's totient rule or totient function. Okay, na? That means what is the formula? If any composite number for getting, any composite number is expressing as p1 power n1 into p2 power n2 and so on like this, where p1, p2 are prime numbers, n1, n2 are their exponential forms, right? Therefore, number of co-primes or number of positive integers according to totient rule is the number into 1 minus 1 by p1 into 1 minus 1 by p2 and so on like this, right? This is the formula we used in our previous class. Okay, same way, what is the 3600 here? Prime factors. Let us express this in prime factorization. So 2 table 2 18 36, here 2 zeros as it is. Again 2 table 9 times, 2 table 450, now 5 table 5 nines 45, 3 table 30 times, 3 table 10 times, 2 table 5 times and 5 table 1 time. So 3600, write in exponential form. The powers we have to write in exponential 2, 1, 2, 3, 4. 2 is presenting 4 times 2 power 4. Next 5 is presenting 2 times 5 square, and last 3 square. But substitute on the formula, composite number is itself 3600 into 1 minus 1 by p1. First prime number is 2, 1 minus 1 by 2. Second prime number is 5, 1 minus 1 by 5. And third prime number is 3, 1 minus 1 by 3. That equals to 3600 into. Write it in a fractional form. 1 minus half. 1 minus half means half. 1 minus 1 by 5. That means 4 ones are 4, 4 minus, 5 ones are 5, 5 minus 1, 4, 4 by 5. 1 minus 1 by 3 is 2 by 3. Now, denominator 2, numerator 2 cancel. 3 table 1200 times. Then what are the remaining? 1200 into 4 by 5 is remaining cancelled. Now 5 table. 5 twos, 5 fours, 240. 240 into 4, 960. Therefore, number of positive integers are 960. Okay, na? Check it. Yeah, let us go to the next sum. Same problem. 2222 whole to the power of 5555. Very huge number. If this number is divided by 7, what is the remainder? See here. Now 2222 is congruent to 2. Let us find the remainder by doing the division. 7 table in 2222. Yeah, 7 threes 21, 1 remainder 2 down, 7 ones are 7, 5 remainder again 2, 7 sevens 49 is 3 remainder. We got the remainder 3. That means we can write 2222 is congruent to 3 mod 7. Okay, na? Right. Next, we need this one up to the powers of 5555. Both sides we are applying the powers 5555 modulus of 7 or mod 7. Okay, na? But according to the previous problem, that is, the remainder should be less than the divisor. Here 7 is the divisor, right? But it is less than the divisor. Here it is more than the divisor. Let us check like previous problem only. I am writing here. That means we need to convert them again. We have to find the remainder from this. That means 5555 is divided by 7. What is the remainder? You should check that remainder only the answer for this also. Okay, 3 square 9. 3 square is 9. 9 can be written as 3 square congruent to 2 mod 7. Not getting. Again 3 cube. We have to try to get up to here remainder 1 or minus 1. 3 cube 27. 27 is congruent to minus 1 mod 7. 27 minus 1 bring this side plus 1. Minus 1 transpose this side plus 1. So 27 plus 1, 28 is exactly divisible by 7. So for 3 cube value, we get the answer. Remainder is minus 1. Now I am taking 3 power. 3 is congruent to minus 1 mod 7. Now extend up to 5555. 3 table 5555 how many times? 3 ones are 3, 25, 3 eights 24. Again 1 remainder 5 down, 3 fives are 15. Again 0, 1s are, here got 2 is the remainder. So less 2 we can increase up to 1851 powers is congruent to minus 1 whole to the power of 1851 mod 7. Here power is odd number, so therefore minus 1 will be minus 1 as it is. If it is even number, minus 1 becomes plus 1. So odd number only, no, we can write minus 1 as it is. For this one 3 power, if you remove 2, you will get 5553 times. Up to here we will get the minus 1 as a remainder mod 7. but we want 2 more. So multiply both sides. 5553 into 3 square is congruent to minus 1 into 3 square means 9 modulus of 7. Okay, na? So this will be 5555 is congruent to minus 1 into 9 is minus 9. But 7 table minus 9. Negative integers are not accepted, no? Remainder negative 9 is coming. That means divisor is 7. 7 minus 9. So 7 is not coming, that 14. You can take 7 table. 7 2 is 14. 14 minus 9. 14 minus 9 is 5. Therefore, the remainder is 5. Done. Okay, next problem. Same problem, 16 power 3500 is divisible by 17 or not. Let us check the first 16. Directly we are getting 16 is divided by 17 means what is the remainder? Negative 1. We get directly. So you can write 16 is congruent to negative 1 mod 17. Okay, na? Now extend up to powers. How many? 3500. Here also minus 1 whole to the power of 3500 mod 17. Right? 3500 is even number. Then minus 1 become plus 1. 16 power 3500 is congruent to 1 mod 7. Therefore, the remainder is 1. Done. Completed. Yeah, please note it. So that's it for today, children. Thank you one and all. Have a nice day.